someone may bring observation, this is why lipids make more energy than carbs. Yes, that's correct. So again, triglyceride, 1 glycerol, 3 fatty acids. You do lipolysis, and you break it apart into glycerol and fatty acids. Now glycerol, this can if you want to break it down into energy, you can shuffle it around, generate pyruvate, and then you have acetyl-CoA that goes into your citric acid cycle. Now fatty acids, beta oxidation is going to generate a bunch of acetyl-CoA. Again, how much acetyl-CoA? Well, remember acetyl-CoA has 2 carbons, so you just take how many carbons are in a fatty acid, divide by 2, and that's how much acetyl-CoA you can generate from a fatty acid. And the other thing is not just acetyl-CoA. Every time you do beta oxidation, you do a round where you snap off these 2 carbons, you also generate NADH and FADH2. So if you keep on doing this and dividing up fatty acids carbon chains, you're going to generate a whole bunch of acetyl-CoA, a whole bunch of NADH and FADH2. Now where does this go? Well, this is what do we get from glycerol? From glycerol, or even like if we had a glucose molecule with 2 pyruvate, you would only get 2 acetyl-CoA. But if you have a single fatty acid that has maybe like 12 carbons, you would get 6 acetyl-CoA. And not only that, you're also building up NADH and FADH2 before you even get into the citric acid cycle. So this is why you have a lot more potential energy from triglycerides and fatty acids. You have a lot more acetyl-CoA, a lot more NADH, and a lot more FADH2 per fatty acid than you do per glucose molecule. And where does this all go? Well, this all goes into the citric acid cycle to generate some ATP, but mostly a whole ton of NADH and FADH2. How much do you generate? Well, depends on how much acetyl-CoA you have from those fatty acids. And this was only 1 fatty acid I'm showing here. If you have like 3 fatty acids, however many carbons are in those fatty acids carbon chains, that's how much acetyl-CoA you can potentially generate. So this is why you have much more energy per fatty acid or triglyceride than you do per glucose molecule. So again, the process of breaking down a fatty acid into acetyl-CoA is beta oxidation. And then glucose, you have glycolysis, and then to break it down to pyruvate. So again, remember that fatty acids are broken down via beta oxidation into acetyl-CoA. Glucose you break down via glycolysis into pyruvate. And the glycerol from a triglyceride can also become pyruvate as well. Now, the thing is that per fatty acid, you generate more acetyl-CoA because, again, carbons divide by 2. That's our beta oxidation. And only 2 acetyl-CoA per glucose. And why is that? Well, again, you snap apart that glucose into 2 3-carbon molecules that become a 2-carbon acetyl-CoA. So you're only going to get 2 acetyl-CoA per glucose. And this is why there's more energies, because again, you're generating more acetyl-CoA, more NADH, more FADH. All of these have energy compared to glucose. This is why fatty acids have roughly 9 kilocalories per gram versus glucose only 4 kilocalories per gram. And other general properties, fatty acids are hydrophobic, glucose is hydrophilic. So this is another reason why your body prefers glucose, because which is easily transported in your blood. What is your blood? Well, you have your cells, but you also have your plasma that is mostly water. So fatty acids have a harder time traveling, especially outside of this just by itself. What we call free fatty acids, they're not very soluble. You do have a little bit of them in your blood, but fatty acids are hydrophobic and they don't dissolve well in your blood. So difficult to transport versus very easily to transport. So again, this is why your body loves glucose. Very easily redeemed for energy, very easy to transport throughout your body. But the thing is that this is why fatty acids and triglyceride, well, when we eat a lot, do we get big stores of glycogen, or do we get big stores of triglycerides and adipose? This is why we store our excess energy as adipose. It's good for long-term storage, but it's a lot harder to transport and break down into energy compared to glucose molecules. So glucose, you can easily absorb it into cells, make a glycogen, or break down glycogen, make it glucose that release it back into the bloodstream. So this is why glucose is preferred by your body.